I really hope I hit record. Did I hit record?
Maybe, maybe not.
If not, I'm gonna have to figure it out later. All right, kites and rhombi. So, last time we talked about area of trapezoids, parallelograms. We have two different formulas for those. Today we're learning kite and rhombus, but guess what? They're the same formula. But before we talk about what the formula is, because I know I could just tell you the formula, right? But I think you're more likely to remember it if we understand why it works, based off of triangles and rectangles. Because if you remember the formula for a rectangle and the formula for a triangle, they're both like that. You can almost get every formula from those two formulas. Okay. So first, let's talk about what a kite is. I'm gonna do speed version here. All right. Oh gosh, it's not a great picture, but that's okay. Here's our kite. I'm gonna add some tick marks. Do you remember what tick marks mean? Those are the congruent. So those two sides right there are the same, and these two sides right here are the same. So the kite has two sets of congruent sides. And there's one more property that you probably don't know, but you might like, it might be very intuitive, like it makes sense. Alright? So here's what that property is, alright? Hang on, I'm gonna be fancy. Okay. Alright, if I draw some dotted lines here, now it actually looks like a real kite, doesn't it? Like the kite that you fly. If I draw those two dotted lines are perpendicular. What does perpendicular mean?
Diagonal.
Diagonals just are what we call these dotted lines are called diagonals. Alright, it's like across the shape, right? That's what diagonal means, goes across it, right? So these two diagonals, what do we know about those diagonals? What did I add to the picture? The right angle, right? So the diagonals are perpendicular. That's what perpendicular means. It means they make a right angle. Perpendicular, which means makes a 90-degree angle. So the diagonals are perpendicular. Okay, questions? Does anybody know how a rhombus is different than a kite?
Rhombus is usually more.
Rhombus like all of them sound the same.
Is that what you're saying, Rob?
Yeah, like equal lengths of sides.
Yes. So now, and you said usually, I'm going to go farther. I'm going to say always. A
Yeah,
rhombus
always.
always has 4 equal sides. So it's the same thing. We're going to draw it similar.
It's basically kind of just like a tilted square.
It's like a compressed square, yeah.
Yeah.
And actually, a square is a rhombus because it has 4 equal sides, right? The only thing that the rhombus doesn't have that a square does is the 90-degree angles in the corners, right? So this one, instead of having 2 sets of congruent sides, look at this, guys, look. Be smarter, work smarter, not harder.
They work hard too.
And then look, just erase that one number and write 4 sets. Actually, just 4 congruent sides. And then the same property applies for the rhombus, is that the diagonals are perpendicular. I have a question for you. Look up here. Look up here, guys. Or if you're watching the video, because I'm recording this right now, look at this. What? I can't zoom in any farther. What shape is that?
Right angle.
Rectangle. Triangle.
A right triangle. what property do we know uses right triangles? Pythagorean theorem. Guess what you're going to be using today? Pythagorean theorem. Every time? No. Sometimes, yes. Okay? Alright. Let's take a look at this kite. I was going to have you explore, but if you're watching the video, obviously you can't explore, or right now we ran out of time because we spent too much time on that game, which is great. It's good to review. It was a fun game, I think. I hope. But I want, instead of exploring, I'm going to show you why this formula works, why the formula that we're going to come up with works, alright? We got a shape here. We could split that into two triangles. Some people might have taken this, like, this triangle here and, like, drawn it over here, which works, right? But I want to show you the way that I'm going to split it up so that it makes the most sense when I'm talking about the formula, okay? And that's like this, diagonal, up and down, vertical. Because now I split it into two congruent triangles, right? Okay, so if I'm finding the area of this shape, what I'm going to do is I'm going to find the area of one of these triangles, and I'm going to multiply it by 2, right? So this triangle right here, the base and the height, what are the, if we just look at sideways, look at the left triangle right here, what's the base of that triangle?
5. No.
Right. I think the base is the vertical line, like this is the base to me, right? Because it's like the one that I can count. I can't count this one. I can't count that one. Why can't I count those?
Because
They're diagonal, yeah. Alright, so I can count this one. That one's 10. Or 15, sorry. And then the height has to be perpendicular. So the height has to be right there. So our height is, what, 5? Okay, so in my, if I'm doing the problem, the area problem, I'm doing base times height. Just base times height?
No, divide by 2.
Divide by 2, because it's a triangle. But then I'm going to multiply the whole thing times 2, right? Okay. So 15 times 5 divided by 2. The 2's are just going to cancel. I'm just going to do 15 times 5, right? That's just 75. You know you can do that if you're doing a multiplying and dividing by the same number. You can just cancel them out.
Yeah.
Now you know. If you didn't know, now you know. As long as they're the same number, you just cancel them out. Okay, so now let's come up with a formula, right? Alright, let's talk about what these numbers represent. The 15 represents that whole distance across, right? Do we call that the base? Do we call it the height? What do we do?
It'd probably be close. In this specific example, it's closer to height, but like.
Yeah.
I mean,
Height of that
usually-
shape, right? What did I call these lines before? Diagonals, alright? So I'm going to call it a diagonal here, because technically it can be the height, but then this isn't really the base, right? It's like the width. I mean, it really doesn't matter what we call it, but we know that I'm going to call them diagonals because that's technically what they are, alright? So I'm taking the diagonal, that was the 15, right? That's the first diagonal, diagonal 1, times this part right here, this height. What does that represent? That's not the whole diagonal, is it? It's half of the second diagonal, right?
Mm-hmm.
So this is like diagonal 2 over 2. And then we divided by 2 and multiplied by 2, right? So I'm just taking what we did here, and instead of the numbers, I'm putting in what they represent. Does that make sense? I'm putting in what they represent. This 15 represented the first diagonal, okay? The 5 represented half of the second diagonal. Okay, so then we said, oh, these cancel out, right? So now all we're left with is D1, oops, D1 times D2 over 2. Now you're like saying, how'd you just end up putting that 2 over the whole thing? Because division and multiplication, like, it doesn't matter which order we do them in, right? We can do the times first or we can divide first. It doesn't really matter what we do. So I just clumped it all together to make it look nice, okay? So here's our formula, right there. That's our formula for kites and for rhombuses. Diagonal 1 times diagonal 2 over 2. If you forget that formula, could you just break this up into triangles and find the area of each triangle? Yeah, of course. Is it more work? Probably.
Yeah.
Yep.
Right? Okay, So let's do one example. Which one do we want to do? Let's do this one. I'm telling you the answer right here, 39, but let's see how we get it. All right, we're going to use our formula, D1 times D2 over 2. So what is our first diagonal?
Nine.
It could be 9. Well, how are we getting 9? It couldn't be 9. What's the whole length?
13.
13, there we go. 13 is our first diagonal. And our second diagonal is,
3.
the
Six.
whole thing
6.
is 6. We have to add up those two 3's,
Oh.
right? So 4 plus 9, that was the 13, and then divide by 2. What's that, 39? So our answer is 39 square meters. Dang, I have a line for the area formula right here. If you want to write it again, you can. That's a rhombus formula, if you want to. Okay, cool. Questions so far? Can we do a fist of 5? 5 is like, I totally get it, I'm good. 1 is like, I'm really confused, I need help. Okay, what are questions we have before I move on?
So instead of doing like dividing it by, timesing it by 2, you just do the whole thing?
Yep. Okay, I have a question for you. Do you think you can tell the difference between a kite and a parallelogram?
Yes.
How do we tell the difference between a kite and a parallelogram?
Kites are more pointy.
Kites are more pointy.
Yeah.
I mean,
Parallelogram don't touch.
that's pretty pointy.
Parallelogram go in a straight line, and kite it
The
kisses
rhombus.
each other.
Yep. Well, what about the difference between a rhombus and a parallelogram?
Rhombuses have equal sides.
Yep. They do. Could a parallelogram have equal sides?
Yep.
It could. Can it be a rhombus and a parallelogram at the same time? It can. So really, guys, you could use either a rhombus formula or a parallelogram, but it's about what information they give you. Like, right? Like if I'm here and I give you this information, this height is 4 and this base is 3, I'm going to use parallelogram, right? Because that's easy, base times height. If I gave you some diagonal information, like that, like this is, I don't know, 12 and this is 14 or like 7 or something. If I give you diagonal information, use the kite formula. Could you use either? Yes. Is one always going to be easier than the other? Yes. So just think smarter, not harder, okay? Okay. Last example, I don't even know if I want to do. Oh, I can do it, guys. What's different about this one? Everything. First of all, we've got the cross going on in the middle, so I'm probably going to use rhombus formula, or diagonal with that, right? Okay, so if I'm trying to do the diagonals, do I have both diagonals? I know A to C is 16. Do I know this other diagonal length? Nope. So I don't know that length. So this is where, guess what comes into play? Pythagorean theorem. Everybody's favorite.
I know.
Okay, so what is my 8 is right here, my 10 is right here. So I need to find this bottom part, right? Okay, so how should I set up my Pythagorean theorem? I wrote it backwards from what you said, sorry. Cool, so I'm just gonna solve this. Hopefully this formula is getting to the point where it's like routine for you.
Oh, really?
And if not, that's why we do math review. Maybe we need to practice extra hard. Okay, x equals 6, bam. That means this part is 6, and this part is 6. Right? I understand, guys, that I am going quite fast. Just know that I'm recording this, so if you want to go back and listen again, you can do that. Okay. D1 times D2 over 2. Okay, what's my D1? 16. I am then times this one, boop, 12. What was that, 94? 96, thank you. I can do 12 times 8 in my head.
Are you sure?
I mean, I can. I just, we make mistakes sometimes.
We all do.
Even math teachers make mistakes.
Oh my gosh, really?
Hey, questions? Hey, I know guys, I'm using all your time, work time, I'm sorry. You have all weekend though, so it's not like a one night thing. Okay, the last example, it says given that A equals 480 units, find the length of the second diagonal. Okay, because we know the first diagonal is 16, right? So I'm going to add that as part of my formula, D1 times D2 equals over 2, right? So I know my first diagonal is 16. I don't know the other one, so I'm going to call it X. So how do I solve this? It's not an equation yet. How do I make it an equation? Sorry, I just got lightheaded. I think I locked my knees.
16.
Equals what? Do we know the area? We know the area. Area is 480. You could divide 16 divided by 2, right? Okay, look up here. I know you're getting distracted and all this stuff. It's almost the end of the period. We can simplify this. 16 divided by 2 is 8. And now it's just a simple one-step equation. How do I get x? Divided by 8. But do you see how I set it equal to what I knew the area was? I knew the area was 480. What is that, 60?
Maybe.
I ain't gonna write down long words.
You don't have to.
Okay, good.
Nobody
Yeah,
will
it's
Diagonal
60.
1 or diagonal 2?
do.
Cause I say it would be too long to write.
I could just do D2, but I don't know why I didn't.
I made you too.
Cool. Any questions? Oh, good. I was recording. Yay!
The reason why I asked is because of the ink of the red.